What if I told you the most advanced robots ever built aren't on Earth? 250 miles above Earth, something extraordinary happened. Robots designed to be humanity's partners in the cosmos became something more. Some can sign, some can shoot, and some nations are racing to weaponize the final frontier. This is the story they didn't tell you. The patents, the politics, and the very real arms race happening above our heads right now. December 2010. NASA had a problem that was costing them millions. Astronauts in pressurized suits couldn't perform delicate repairs. Every hand tool required 3 times the normal grip strength. Simple valve turns took 15 minutes. Something had to change. Enter Robonaut 2. Not just a machine, a $2.5 million gamble that NASA and General Motors co-developed to bridge the gap between human ingenuity and robotic precision. Watch this. A human hand has approximately 27 degrees of freedom. R2's hands, 42. It could grip with the delicacy needed to handle a raw egg, or the strength to turn a valve requiring 20 pounds of torque. On February 24, 2011, R2 launched aboard Discovery's final mission. It became the first humanoid robot to live on the International Space Station. But NASA had a bigger plan than anyone realized. Then came the moment that made roboticists around the world pause their work and watch. This wasn't programmed showmanship. This was NASA proving that human-robot collaboration could be personal, emotional, revolutionary. But R2's real impact wasn't in space. It was in the 39 patents that followed, including one that would revolutionize factory work on Earth, the Robo-Glove. Inspired by R2's hand design, this device amplifies grip strength by 75%, reducing fatigue and injury in workers who perform thousands of repetitive motions daily. Then came X1, a robotic exoskeleton that could either assist or resist leg movement, designed for both space rehabilitation and helping paralyzed patients walk again. While NASA celebrated collaboration, Russia was building something different. Fedor wasn't designed for delicate manipulation like R2. It was designed for one thing: complete human motion replication, an avatar for cosmonauts to control from Earth. The concept was brilliant. No astronaut risk. Full human decision-making. Complete dexterity. But there was one problem. The first automated docking attempt failed. 3 days later, they tried again. This time, success. Fedor performed its duties for 10 days. Basic tool operations, system checks. But its 350-pound frame was designed for open spaces, not the ISS's narrow corridors. On September 7th, Fedor returned to Earth. The mission was complete, but questions remained. And then, this happened. Hold on, let's talk about what actually happened here. The gun demonstrations were never about combat. They were about proving fine motor control. If a robot can handle the precise trigger control of firearms, it can handle delicate repairs, medical procedures, or hazardous material manipulation. International law explicitly prohibits weapons in space. Fedor carried 0 weapons to the ISS. None. But the damage to public perception was done. But here's what should concern us. While Fedor was being grounded, other nations weren't stopping. They were accelerating. China's publicly stated purpose? Debris cleanup. The official narrative is environmental, removing dangerous space junk that threatens active satellites. The challenge with dual-use technology is intent. A robotic arm that removes debris can also disable communications. A gentle nudge system can become a weapon depending on who controls it and why. The United States isn't staying idle. The Space Force, established in 2019, has publicly acknowledged developing satellite protection systems. The details? Classified. So we face a question humanity has never confronted before. Can space remain peaceful when defense and aggression use the same technology? But here's what gets lost in the militarization debate: the extraordinary potential of space robotics for humanity's benefit. NASA's Artemis program plans to return humans to the moon by 2025. But before astronauts arrive, robots will build habitats, test life support systems, and create infrastructure. Robonaut 2 and Fedor represented different philosophies. NASA chose dexterity and specialization. Russia chose human replication and strength. But both proved one thing conclusively: we can build machines that work alongside us in the most hostile environment imaginable. The question isn't can we, It's, will we use them wisely? 250 miles above Earth, the next generation of space robots is already being designed. More capable, more autonomous, more controversial. These robots scare us because they represent our own capabilities amplified. They inspire us because they show what we can achieve together. The choice of which reaction wins, that's up to us. If this story changed how you think about space robotics, hit that subscribe button. Next time, we're covering the robots that will build humanity's first lunar base. Trust me, you don't want to miss it.